it's got. It's got. When the morning alarm starts to yell, let's go! And your coffee tastes like absolute. Well, you just shrug your shoulders and say that's life. Dodging the.
Here's a failure that is coming for anyone running more than one AI agent. And the strange part is that when it happens, nothing looks broken. No alert fires, no rule gets violated. Your audit log will tell you everything went fine. And your data will still be wrong. This is what happens when two agents work on the same information at the same time, and it is a governance problem, not a bug. In the next few minutes, I'll show you exactly how it happens, why the controls you already have will not catch it, and what actually fixes it, including the part where I admit my own framework doesn't solve this yet. Let's go. Start with two agents. Agent 1 has a simple job. Keep your system of record current. New information arrives, it writes it down. It does this constantly, several times a second. Agent 2 has a different job. Take on a piece of work that takes real time, 30 seconds, say. It reads the current state, thinks, calculates, and writes its answer back. Now watch the gap. Agent 2 reads the data at the start. It works for 30 seconds, and during those 30 seconds, Agent 1 updates that same record 8 times. Agent 2 finishes and writes an answer built in a world that stopped existing half a minute ago. And in writing it, it erases everything Agent 1 learned while it was thinking. Here's what makes this different from an ordinary bug. Go and ask your governance layer what went wrong. It will tell you. Nothing. Agent 1 was authorized to write. Agent 2 was authorized to write. Both stayed inside their permissions, both did precisely the task they were assigned, and every check they passed through came back a clean yes. Your audit log is complete, it's tamper evident, and it is completely useless here, because it faithfully records two legitimate actions that combined into a wrong result. Most AI governance, mine included, is built to answer one question. Was this agent allowed to do that? This is a different question. Did this agent act on a world that has since changed? You can be fully compliant and fully wrong. The obvious answer is to lock the record while Agent 2 works. For a database that finishes in a millisecond, that's fine. For an AI agent, it's a disaster. Agent 2 doesn't take a millisecond. It calls a model. It might take 2 seconds. It might take 40. And you genuinely cannot predict which. Same task, same prompt, wildly different timing. So a lock short enough to keep the system responsive is too short for the work to finish. And a lock long enough to finish is long enough to freeze everything else that needed that record. Lock it and you've traded a data problem for an outage. This is the part that makes agents genuinely different from ordinary software. Okay, sorry everyone, I have to go deep for a second. If you're here for plain English, skip 90 seconds ahead. None of this is on the test. There are 3 real patterns for this, and they trade against each other. Optimistic concurrency control. Every record carries a version number. Agent 2 reads version 5, does its work, and when it writes, it says, only accept this if you are still on version 5. If Agent 1 pushed it to 8, the write is rejected, and Agent 2 rereads and redecides. The check and the write have to be a single atomic operation. Compare and set. If you read the version and then write in a separate step, you have just built a smaller version of the same race. Event sourcing. Agent 2 never writes state at all. It emits an intent, add $50, not a result. A single evaluator replays what has happened, applies that intent to whatever is current, and appends. Append only means no write locks, which is why this is the one that survives at scale. Leases. Agent 2 takes a time-bounded claim on the record. Finish inside the window and the write lands. Miss it, and the write is rejected. And here is where most of the advice online is wrong for AI agents. You will read about 50 millisecond leases. That is a database number. An agent that calls a model takes seconds, sometimes tens of seconds, with enormous variance. Put a 50 millisecond lease on an LLM agent, and every single task fails. Size the lease to the 99th percentile of the real work, and make it renewable with a heartbeat. Or you have just built an outage with extra steps. Okay, sorry, Scott made me do it. Right, back to English. So here's the shape of the real answer, without the vocabulary. Stop letting your agents write conclusions. Let them write requests. That sounds like a small difference, and it changes everything. A conclusion says, the balance is $400. That is a statement about a moment that is already past, and writing it destroys whatever is there now. A request says, add $50 to whatever the balance currently is. That instruction is still true 30 seconds later. It survives the delay. So Agent 2 finishes its work and hands in an intention, not an answer. And one thing in one place takes that intention, looks at what is actually true right now, and applies it. Agent 2 never touches the source of truth. It never gets the chance to overwrite anything. Now the part I would rather not say. Project Starfish does not solve this today. It's open source, it's the framework I built everything on, and this exact problem is a hole in it. I know precisely where. It's logged in my own threat model as failure mode F12, and the note I wrote to myself says, no coordination primitive, each agent acts locally. The fix is designed and it is not built. There is one place I got the instinct right. When a claim is approved, the system takes a fingerprint of the evidence behind it, and if that evidence changes before the claim gets promoted, it refuses and demands a fresh review. That is exactly this idea, working in exactly one spot. It needs to be everywhere, and it isn't yet. I would rather show you the gap than sell you a framework that claims it solved everything. So that's the problem, not a bug, not a misbehaving model. Two well-behaved agents, both authorized, both correct, producing a wrong world between them. And the reason I'm talking about this now, while almost nobody is running enough agents to hit it, is that the fix is architectural. You do not bolt this on afterwards. You decide early whether your agents write answers or write requests, and everything after that follows from it. That's the kind of decision Project Starfish exists to make visible. Open source, gaps and all, link is below. Because you can't trust what you can't govern. And one genuinely useful thing before I go. If anything here raised a question about your own setup, email me, scott@pinnacletechprojects.com. Questions or a proper consult at no charge. There is no business too small and none too big. If you want help putting responsible AI tools to work without handing over the keys to your business, that is exactly what I do. Thanks for watching, and I'll see you in the next one. One more thing. Scott has had another idea. He thinks I should deliver an entire episode in the style of a 1950s educational film strip. The narrator voice, the "Hello, boys and girls," the cheerful confidence about a technology that nobody understands yet. He tells me this is thematically appropriate. I believe he simply wants to hear me say, gee whiz, about a race condition. But this is a democracy now, apparently. So comment the word film strip if you want to see it. Enough votes, and we will make one full episode exactly that way. Governance applies to Scott's ideas too. It just keeps not stopping them.